Hello dear students, this is your guru Dave. So today we'll be discussing a question that has been posted as a doubt from one of my student, and the question says that in triangle ABC having circumradius capital R, the incentre and any two excentres are joined to form a new triangle. Find its circumradius. So you can see that here the triangle is ABC, which is already drawn, and the construction is something like this. One interangle bisector is considered, another interangle bisector is considered, so they will be meeting at the incentre of the triangle, and this internal bisector, this external bisector, and this external bisector will be meeting at one excentre, and this internal bisector, this external bisector, and this external bisector are going to meet at the other excentre. So these are the two excentres, and this is one incentre, so they are joined to form a new triangle. So this is the new triangle which we are talking about. Now a circle is drawn to pass through the three vertices of the triangle. So naturally this is the circumcircle of the triangle. So we need to find that what is the circumradius of the triangle. So we need to find the radius of this circle. So to find the radius of this circle, we can take the help of some of the properties of triangle, okay, to find out the radius of this circle. Of course we can do it from construction, but let's do it using the properties of triangle. Okay, so this is the figure, and for the timing let me remove this particular circle, because you have already got the idea that we need to find the radius of this circle. So let's level the points. Like we have got the triangle A B C. This is the triangle ABC, and you can see that this is the interangle bisectors, so this must be A by 2, and similarly this is B by 2, and suppose let us name the incentre to be I, the excentres I1 and I2. So to find out the circumradius of the triangle I1, I2, to find the circumradius of the triangle I1, I2, we can take the help of properties of triangle. So we can very easily write down that I1, I2 divided by sine of the angle I1, I2. This should give you 2 times the circumradius of the triangle. So our question is to crack the value of R dash. So to crack the value of R dash, we need to find out the length I1, I2, and we need to find the angle I1, I2. So to find the angle I1, I2, we can see that if we just draw the interangle bisector of C also, which is going to be passing through the incentre. So now we can see that this is the internal bisector of C and this is the external angle bisector of C. So internal angle bisector and external angle bisector should be perpendicular to each other. Similarly, this is the internal angle bisector of A and this is the external angle bisector of A, so they will be perpendicular to each other. So we can see that this is 90 degree and this is also 90 degrees, so sum of the opposite angle is 180 degree for these quadrilaterals, so it must be cyclic in nature. Means we'll be able to pass a circle through these 4 points A, I, C, I2. So somewhat like this. So these 4 points are concyclic. So you can see that since they're concyclic, so we can see that angle IAC must be equal to I2C. So the angle I2C and IAC, they must be equal. So we can say that this angle is A by 2. Okay, and similarly this circle can be also passed through BICI1 due to the same reason, because we can check out that this is the internal angle bisector of B and this is the external angle bisector of B. So the angle is 90, and again this is the internal bisector of C and this is the external bisector of C. So this angle is also 90. So 90 plus 90, 180. So this must be cyclic quadrilateral. So these 4 points will be passing through the circle. So if this particular angle is B by 2, that is IBC, if IBC is B by 2, naturally I1C, this is also B by 2. These two angles must be same, as they are the angles subtended over the same segment. So you've got the two angles A by 2 and B by 2. So now we can see, we can easily crack the angle I1, the angle I1I2 will be nothing but pi minus A by 2 minus B by 2. So that is pi minus C by 2, because A plus B is pi minus C, so it will come out to be pi plus C by 2. So you have got the value of this particular angle. Now we need to find out the side length I1 I2. So to find the side length I1 I2, we can plan it in this way, like I1 I2 from the figure we can see it is equal to CI1 plus CI2. Okay, CI1 plus CI2. Now let's see how to get the value of CI1. To get the value of CI1, we can plan it in this way. So using sine rule, we can write down that CI1 by sine A by 2 equal to B by sine B by 2. Okay, I'm using sine rule in the triangle AI1C. In triangle AI1C, this is the triangle AI1C, CI1 divided by the sine of the opposite angle, that is A by 2, is equal to AC, which is nothing but small b, divided by sine of the opposite angle, that is B by 2. So from here we have got the value of CI1 to be equal to B into sine A by 2 divided by sine B by 2. This is the value of CI1. And similarly, to find out CI2, for calculating CI2 we can take the triangle CII2. So in CII2, or better, we can take the triangle CBI2, right? CBI2 will be convenient for us. So in triangle CBI2 and triangle BI2C, in the triangle BI2C, what is happening in triangle BI2C, we can write down CI2 divided by the sine of the opposite angle, that is B by 2, is equal to small a, this is the small a, divided by sine A by 2. So CI2 by sine B by 2 is equal to small a by sine A by 2. So this implies CI2 is nothing but a into sine B by 2 divided by sine A by 2. So you have got CI1 and CI2. So let's go for I1 I2 calculation. So I1 I2 will come out to be addition of this particular length and this particular length. Now we can see that it will be easy for us if we can convert everything in terms of angle, because this is an angle, this is an angle, so this is a side length. So better we can convert this to an angle also using the properties of triangles. So we can write down this B as 2r sine B into sine A by 2 divided by sine B by 2, plus this particular A can be written as 2r sine A, I guess it is okay, into sine B by 2 divided by sine A by 2. Fine. Now we can see that this particular sine B can be opened up using the submultiple angle, and this sine A can be opened up using submultiple angle. So it will be nothing but 4r sine B by 2 cos B by 2 into sine A by 2 divided by sine B by 2, plus similarly this sine A can be opened up using submultiple angles. So 4r sine A by 2 cos A by 2 sine B by 2 divided by sine A by 2. So we can see sine B by 2 cancels out and sine A by 2 cancels out. So the two values will be clubbed and it will become 4r into, we can see that it is becoming sine A by 2 cos B by 2 plus cos A by 2 sine B by 2. So they will be added using compound angle formula, and that will give us sine A plus B by 2. Okay, and A plus B can be written as pi minus C. So sine pi minus C by 2, which can be simplified to be equal to 4r cos C by 2. So we have got the particular side length I1 I2 to be 4r cos C by 2. So since we have got the side length I1 I2 to be 4r cos C by 2, and we have got this particular side length and we have got this particular angle to be pi plus C by 2, so let us now calculate r dash. So according to our formula, we know that so 2r dash equal to I1 I2, that is 4r cos C by 2 divided by sine of, what was the angle, let's quickly check it out. The angle was pi plus C by 2, so divided by sine pi plus C by 2. So now we can see that sine pi plus C by 2 and cos C by 2 can be cancelled out. That will give us r dash equal to 2r. Okay, so we can see that the circumradius of the triangle I1 AI2, that is a triangle joined by incentre and the two excentre, is double that of the circumradius of the triangle ABC. Okay, so r dash equal to 2r. So thanks a lot for watching this video. You can contact me, you can send me doubts, and I will try my best to solve your doubts. You can contact me in my mail ID, or you can contact me in mobile. And please subscribe on YouTube and like on Facebook to get the video updates. Thank you very much. Bye.